Welcome back to Introduction to Symbolic Logic. This is lecture 3. Our main topic for today are truth-functional connectives. As we will discuss in just a second, truth-functional connectives are such that their meaning can be represented by means of truth tables. So we are going to talk about truth table a lot today. In the first step, we are going to discuss what truth-functional connectives are. We are then going to contrast truth-functional connectives with non-truth-functional connectives. We are going to see how to construct truth tables for more complex sentences. And then finally, we are going to see how we can use truth tables to assess the logical properties of specific sentences. So let's start by discussing the nature of truth-functional connectives, what they are. A connective is truth-functional if and only if the truth value of a sentence with that connective as its main logical operator is uniquely determined by the truth values of the constituent sentences. So for example, think back to the disjunction sign. The disjunction sign is truth-functional for the following reason. A sentence of the form A or B is true if and only if at least one of either A or B is true. And so that means that the truth values of A and of B uniquely determine the truth value of the disjunction A or B. And that just is what's required for the disjunction sign to be truth-functional. Now, an equivalent way of describing truth-functional connectives makes use of the notion of a function. We can say that a connective is truth-functional if and only if the truth value of a sentence with that connective as its main logical operator is a function of the truth values of the constituent sentences. So you can think of a truth-functional connective as a function that takes the truth values of the constituent sentences as input and delivers the truth value of the composite sentence as output. We can represent the meaning of truth-functional connectives by means of a truth table. So for example, here you can see the characteristic truth table of the negation sign. In the right column, you see the sentence not A, whose truth value we want to determine here. And in the left column, you see the possible truth values for A. And what this table tells you is that if A is true, not A is false. And if A is false, not A is true. And so you can see that the truth value of not A is a function of the truth value of A. If we put in the truth value t as input into this function, it delivers the output f. And if we put in the truth value f as input to this function, it delivers the output t. And so that means that the negation sign is a truth-functional connective. Let's talk about the parts of a truth table in general terms. So you can see that this truth table has two main columns, one column to the left and one column to the right. The column to the left we call the reference column. The column to the right we call the assessment column. At the top of the assessment column, you see the sentence that we want to evaluate. And at the top of the reference column, you see all the atomic sentences that appear inside the sentence that we want to assess. Now, below the atomic constituents of the sentence that we want to assess, you see the possible assignments of truth values to this constituent sentence. So this sentence A is either true or false, and so our reference column contains two rows, the first row containing a T, signaling that this sentence is true, and the second row containing an F, signaling that this sentence is false. And then below the sentence that we want to assess, we see the truth values of the sentence represented as a function of the truth values of the atomic constituents. So those are the main components of a truth table. We have an assessment column, a sentence that we want to assess, a reference column, and the atomic constituents of the sentence that we want to assess. And the truth table then allows us to represent the truth value of the sentence that we want to assess as a function of the truth values of its atomic constituents. So we saw that the reference column of a truth table contains all the possible assignments of truth values to the atomic constituents of the sentence that we want to evaluate. There's a technical name for that. A so-called valuation is any assignment of truth values to particular sentence letters of TFL. And what that means is that the reference column of the truth table for a sentence A needs to contain every possible valuation of the atomic sentences that appear in A. A consequence of what I just said is that the more atomic sentences we have, the more complex the reference column for a truth table will get. In our example of the characteristic truth table for negation, we just had one atomic sentence, namely A. And so the reference column for this truth table contains only two rows, one in which A is true and one in which A is false. Now, if we assess a sentence with two atomic constituents, A and B, the reference column for that truth table will need to contain four rows. The first row represents a possible situation in which both A and B are true. The second row represents a possible situation in which both A and B are false. The third row represents a possible situation in which A is true and B is false. And the fourth row represents a possible situation in which A is false and B is true. So that means that the truth table for a sentence with two atomic constituents is going to have four rows. And this pattern repeats itself. So if you construct a truth table for a sentence with three atomic constituents, that truth table will need to contain a row for each possible valuation of the atomic constituents of that sentence. And so that means that this truth table is going to have to contain 8 rows, starting with a row in which all three sentences are true, and ending with a row in which all three sentences are false. Now, just as we represented the meaning of the negation sign by a truth table for negation, we can also represent the meanings of all the other Boolean connectives by means of truth tables. So here's the characteristic truth table of the conjunction sign. we see in the assessment column of this truth table the sentence A and B, and then we see in the reference column one column for A and one column for B, and 4 rows representing all the possible valuations for A and for B. And what this truth table tells us is that the sentence A and B is true only if A and B are both true. In any other possible situation, meaning the situation in which both A and B are false, or in which only one of the two sentences is false, in all these other situations, the conjunction A and B is false. Here we see the characteristic truth table for disjunctions. So on top of the assessment column, you see the sentence A or B. It again has 2 atomic constituents, A and B. So that means that our truth table is going to have 4 rows representing all the possible valuations for A and B. And the truth table then tells us that the disjunction A or B is true in every case except when both A and B are false. When both A and B are false, then the disjunction A or B is also false. Here we have the characteristic truth table for the conditional. So on top of the assessment column, you see the conditional sentence, if A, then B. Our truth table again has 4 rows representing all the possible valuations for A and B. And what the truth table then tells us is that if A, then B is true, except for the one case in which A is true and B is false. That's represented in the 4th and final row all the way at the bottom here. Now let's finally look at the biconditional, A if and only if B, represented on top of our assessment column. What this truth table for the biconditional tells us is that A if and only if B is true just in case both A and B have the same truth value, meaning in case both A and B are true or both A and B are false. In the 2 cases in which A and B have different truth values, the biconditional A if and only if B is false. We can sum up this discussion again by means of a truth table. So here you see a truth table that summarizes the 5 truth tables that we have seen so far. To the left in the reference column, you see the 2 atomic sentences A and B and the 4 possible valuations for A and B. And then in the assessment column to the right, you see 5 columns, 1 for each of our 5 Boolean connectives. And what this truth table brings out is that each one of our 5 Boolean connectives is truth functional, since we can represent the truth value of sentences that have any of these Boolean connectives as their main connective as a function of the truth values of its constituent parts. Okay, we have discussed what truth functional connectives are, as well as the characteristic truth tables for our 5 Boolean connectives. In the next lecture, we are going to see how you can show that a connective is not truth functional.